Today we are going to be learning about radical equations. Before we start the lesson, let's start with a do now. The square root of x equals 7. To solve this, you have to get rid of the square root, and you do so by squaring both sides. Once you square both sides, you will get rid of the square root effectively and get x equals 49 as your final answer. We're going to be using this basic principle in our lesson. Alright, here are some terms to know really quickly. A radical equation is an equation with a square root, cube root, etc. To solve these problems, you must 1. Isolate the square root, which means moving it to one side by itself, and then squaring both sides as the second step. This will get rid of the square root. However, it's also really important to keep in mind that sometimes squaring can create false solutions which don't work when you plug them into the original equation. So always remember to check your answers by plugging them into the original equation. Let's move to our first example, example 1, a find and fix the mistake. So we're going to look at a student's work and see if we can find where they made their error. The problem is square root of 5 minus x equals x minus 5. The first step is to square both sides. Next, this student simplified. As you can see, they got 0 equals x squared minus 9x plus 20. And from there, they factored that into 0 equals x minus 5 and x minus 4, leading them to say that the answer was that x was 5 or 4. However, there is one really important step we just talked about in the beginning that they missed. See if you can see what it is. Sure enough, they didn't check. You'll see that if you plug in the student's answers 5 and 4 to the original equation, only one of them works, and that's 5. 0 can equal 0, but 1 cannot equal negative 1. So 4 doesn't work and only 5 does. This is an example of how important it really is to check, because although sometimes both of your answers might work coincidentally, most of the time they won't, and only one or even none will. Let's move to example 2. Now, this one is a bit harder because instead of just having one radical, it has 2. So there's going to be more steps to solve this, but the basic steps are still the same. Let's go through this one together. So, step 1. Isolate radical. Subtract radical x minus 1 from both sides, just like we did in the last one. Next, again, you're going to square both sides to try to get rid of those radicals. Next, you're just going to simplify and get 3x minus 5 equals 3 minus 4 radical x minus 1 plus x, then isolate the radicals once more. Again, you still have that 1 radical x minus 1 left, so you got to square both sides to get rid of it. Next, just simplify again. It's really the same steps, so as long as you keep the process in mind, you'll be able to do this, even if it takes a little more time. Simplify again and combine like terms until you can have something that you can set to 0. Now in this next step, I chose to use the quadratic formula and apply it to the equation, but you also could have factored 4x squared minus 48x plus 80. Really either works most of the time, but in this case I just found it easier to use the quadratic formula. Alright, so once you simplify that, you're going to get 48 plus or minus 32 over 8, which then makes the value of x 10 or 2. But don't forget to check. Remember, that's really important. So here we are checking, and as you can see, 10 does not work when you plug it back into the original equation, but 2 does. So the answer is x equals 2. Now, this is really the hardest these kinds of questions are going to get, so if you got this, then you're good to go. Thank you for joining this lesson. Now you're all set to solve radical equations on your own. Thank you!